So hi, guys. This is Christina.
This is Nino.
And today we will talk about
Königsberg's Bridge.
and how we will solve it. Ready?
I'm ready.
Let's go!
You'll have a very difficult time finding Königsberg on any stylish or modern map. A once unequivocal court in its geology has made it a far-renowned urban community in math. A middle-aged German town lay on one or the other side of a river. At the center of the river were two large islands that were associated with each other and connected by 7 scaffolds or bridges. Carl Gottlieb Euler, a man of science who later turned into an official of a nearby town, became obsessed with these bridges or scaffolds. He kept trying to answer one problem.
Try solving the problem that haunted Euler, which route passes all 7 bridges or scaffolds without having to cross a bridge twice. It cannot be solved. It isn't possible. Anyway, attempting to explain why it isn't possible, a very popular mathematician, Leonhard Euler, discovered a fresh out of plastic new field of math while trying to answer why it wasn't possible. Carl kept in touch with Euler for work with the issue. Euler first dismissed the inquiry as it was having nothing to do with math. Anyway, the more he tackled with it, the more it shown up that might be something there after all.
What he discovered while studying the problem was an unadulterated new field of math that didn't as yet exist. He alluded to it as the geometry of position, which was later known to be graph theory. Euler first thought that the course taken between getting into an island or a conduit bank and disappearing didn't genuinely make any difference. Consequently, the plan could be improved with every one of the 4 expanses of land depicted as nodes. What we watch out for now connects a hub with lines or edges between them to address the scaffolds or bridges, and this worked to just count the level of each and every hub, that the quantity of extensions each node contacts. This graph allows us to easily count how many degrees there are on each node. The degrees are how many edges or lines are connected to each node. For what reason do the degrees matter? Let's say a traveler arrives onto an island or a node. They would have to leave on a different bridge. Understand an extension and the scaffolds coming in and from every hub on any space ought to happen in particular pairs, which implies that how much extensions contacting every body of land or node should be even. The sole possible special cases would be the areas of the beginning and finish of the bridges. Noticing the diagram and become apparent that all 4 hubs have an odd degree. In this way, no matter what that way is picked, sooner or later, a scaffold or bridge would have to be crossed 2 times. Euler utilized this evidence to figure out an overall hypothesis that applies to any or all graphs with or 2 more hubs or nodes. A Eulerian path that visits each edge just once is only feasible in one of 2 scenarios.
The first is once there are explicitly 2 hubs of odd degree, and for the rest of the node to have an even degree. There, the beginning line is one of the odd hubs, and consequently the end is the other odd degree. The second is every one of the hubs are of even degree. Then, at that point, The Eulerian way can start and end inside the same area. That furthermore make it known to be a Eulerian circuit.
So anyway, can you create a Eulerian path in Königsberg? It's clear. Essentially just remove any one edge or bridge. Did you know that actually history created a Eulerian path of its own in Königsberg? Back in World War II, the Soviet Air Force bombed Königsberg and in doing so obliterated 2 bridges and thus created a Eulerian path. That, however, was not their intention. These bombings pretty much wiped Königsberg off the map, and it was later renovated to be the Russian town of Kaliningrad.
While Königsberg and her 7th scaffold probably isn't around in this world anymore, it will be remembered over the entire course of time by the apparently small question that promoted the development of a full new field of math known as graph theory.
Newton's numerical transformation, imagined on his ranch while he was in segregation from the bubonic plague, implied that the figure of the mathematician came to be considered as fundamental in European social orders and courts in the 1800 years. Specialists in the field developed from being simple devotees of numbers to becoming regarded experts, equipped for tackling many viable issues, from building and social to ballistic and maritime.
Among the main down-to-earth issues tackled by Euler were the expectation of the periods of the moon at far-off dates, essential data for the planning of tables for sea route, and the improvement of algorithmic technique, a crucial device for mathematics even from that point forward, and one that is as yet involved today in fields like material science, and financial matters. These issues was the beginning stage of Euler to foster a portion of his most significant hypothesis. So, this is how the game works. Connect all the islands in the diagram together using the following rules. Number 1, the number inside each island indicate how many bridges are connected to it.
Number 2, each pair of islands can only be connected to each other by a maximum of 2 bridges.
Number 3, bridges can only connect islands in straight non-diagonal lines. They have to begin and end on an island and cannot cross each other. Euler took the map of the city and developed a minimalist representation in which each neighborhood was represented by a point, also called a node or a vertex, and each bridge by a line, also called an edge. In other words, he represented it with a graph.
From this first graph, he deduced that in order to plot the desired route, and if the starting point is the same as the ending point that is, the route begins and ends in the same neighborhood, forming a closed circuit. Each point should be linked to an even number of lines. Since each time the traveler crosses the landmass, he must enter by one bridge and leave by a different one. If on the other hand, the journey begins and ends in the different places, then the starting and ending neighborhoods can have an odd number of bridges.
The great advantage of topology is that it makes it possible to represent in a very visible way the relationship between different entities and to visualize more better way to reach the desired result or solution.
Here you will see the solutions for all 3 games.
So that will be all. Thank you guys for watching.
We hope you guys were able to learn how a simple math puzzle was able to pave the way for a new mathematics theory.
And guys, don't forget to like and subscribe Ilocano Math TV for more mathematics information. Thank you guys!